Hey everyone, so basically in today's GFG POTD we have a problem to shortest in every subarray. So basically it is an easy level of problem, and as a problem given here, given an array of integer r. So we have an array of integer r. The task is to find and return the maximum sum of the smallest and second smallest element. So basically we need to return maximum element from the smallest and second smallest element among all the possible subarrays of size greater than 1. If it is not possible, then return -1. So as the problem given here, and this problem basically explains about that we have a set of an array where we have to take the subarrays of size which is greater than 1, and uh, we need to return the sum of their subarrays. Okay, and the subarrays are like, we need to take the sum of subarrays like as the format of smallest and the second smallest element. Like for example here, as the example given here 43156. So first of all we have to like traverse this array and check the subarray. So basically if you're talking about the smallest subarray, so we got here 4 and 3. So where 3 is like is minimum element and 4 is called as maximum element, and we will take the sum of it. Okay, so here we get 7. Now again what we have to do, we need to move forward. Okay, that means here, no, in this time we get like 1 is the smallest element and 3 is the maximum element. Okay, and again we need to do what, we need to traverse through like 4 3 1 and 5. Now 5 is the maximum element, as we can say here, where it is here 4 3 1 5. So smallest is 1 and the second smallest is 3. So if we sum this thing we got 4 here. Again if we talk about 6, so till here the smallest one is like 1 and second smallest is like 3. So if we had, we got 4. Similarly we have to like traverse it for all. Like we have to make a subarray like in this format. First of all it will traverse like in this way, then after that in this way, then after that in this way. After that it will like traverse from this 3 1, then 5 6, then after that 1 and 5. At the last if we see this, we got like 5 and 6, and if we add this we got 11, which is the maximum element, and the question says that we need to return the maximum sum of the smallest and second smallest element. Okay, so first of all we have to define about the size of our array. That means here we can give condition that if array dot size is like less than 2, as the problem given here, that the size of that the subarrays of size greater than 1. Okay, if it is not possible then return -1. Okay, so if it is like less than 2, then we need to return -1. Return -1. Okay, then after that what we can do, we need to like traverse inside the array, and we need to store, let's say if I'm declaring maximum value and initialize with 0. Now we need to traverse it inside the array. So for int I is equal to 0, I is less than array dot size -1, and then I plus plus. Now what we have to do here, we need to take the sum of the subarrays where the first element are like a smallest element and the second element are considered to be like second smallest element, right? So for that what we can do here, we need to take if array of I plus array of I plus 1, which is the second element, is like greater than maximum value, then we can say that we need to store those addition of like first smallest element as well as the second smallest element. We need to take inside the array for like max is equal to array of I, then plus array of I plus 1. Now at first iteration what we will get, we actually getting 4 plus 3, which is equal to 7. Okay, so here we get 7. Then after that in this, once we like completed this loop, we need to go for another like for int I is equal to 1, and I is equal to 1 is like we started from 3, so we like take from 3 and 1. So first element is like 3 and second is element is like 1. So if we add this, we got here 4. Okay, like that. So like that we actually, and if we are talking about, if we are going here, that means for int I is equal to 2, we actually getting 5 and plus 6. Okay, and then after that like that we have to like traverse it, and we have to simply return our maximum value, return max value. And this situation is only possible when the values are like greater than maximum value, then it will increment the size of increment the values of the max. Okay, otherwise it will move out and throw -1 for this situation. Okay, or whatever the value the max contains, the previous values. Okay, so we have to solve this problem with an expected time complexity of order n. So this problem is solved using a expected time complexity of order of n. So let's try to submit it. So it's submitted. So that's all for the today. Thanks for watching.